are from Group 5. So today we're going to talk about Experiment C, which is High Performance Liquid Chromatography, Hplc. Now I'm going to introduce our group members. The first one is Nur Alia Mashita, next is me, Nur Afika, next is Nur Janatun Nakia, and Nur Alia Shazwani.
High performance liquid chromatography is an analytical technique used to separate, identify, and quantify compounds in a mixture. It works by passing a liquid sample through a column filled with a stationary phase, while a mobile phase carries the sample components at a different rates based on their interactions with the columns. Hplc is widely used in pharmaceuticals, food analysis, and environmental studies due to its high accuracy and efficiency. Our objective for this study is first to determine the retention time of a standard solution, which is caffeine. Second, to identify the caffeine peak in the soft drink sample. And lastly is to determine the amount of caffeine in soft drink sample using the response factor method.
Explaining about the working of an Hplc system with inline post-column oxidation and derivatization. Let's go step by step through the process. First, pump 1 delivers the mobile phase, which carries the sample through the system. Next is the auto-injector, introduce the sample into the system for analysis. The sample then enters the analytical column where it is separated based on its chemical properties. Next, it passes through the activated charcoal column, which helps remove impurities or concentrate certain compounds. Next is the flow will reach the PTFET, which directs it for further processing. Meanwhile, pump 2 adds OPDA reagent for the derivatization reaction. The mixture then travels through the coiled Teflon tube, which provides enough time for the reaction to take place. To ensure optimal conditions, the column thermostat maintains a stable temperature. The process sample reached the fluorometric detector, which detects and measures fluorescence signals. The data system records and processes the result for analysis. Finally, the waste solution exits the system through the waste outlet. In summary, this system allows for precise detection of compounds by using post-column derivatization, improving sensitivity and accuracy.
So back to me, I'm Naki. I will talk about caffeine analysis using Hplc method. So based on the graph, the rotation time for standard caffeine are 2.482, while peak area of caffeine are 6249.48779. So next, the retention time for caffeine and coke are 2.481, while for the peak area of caffeine are 7001.12305. Next, the retention time for caffeine in Levita is 2.479, while for the peak area of caffeine are 151.1000000. Okay, so for the calculation, to find response factor RF caffeine standard, we use formula peak area of caffeine standard over concentration of caffeine standard. So to find concentration of caffeine ppm in the unknown standard, we use formula peak area of caffeine in sample divided by RF, which is response factor. So the response factor RF for caffeine standard are equal to 62494.8779 mg/ml. The concentration of caffeine in coke are 112.13 ppm. The concentration of caffeine in Levita are 178.43 ppm, which is the composition factor for the composition factor are mg/ml equal to 1000 ppm.
Next, discussion. The high performance liquid chromatography Hplc method is widely used for precise, accurate and sensitive measurement of caffeine levels. In the present research, peak area data and the response factor were used to evaluate the caffeine concentrations in soft drinks and energy drinks. Levita 178.43 ppm and Coke 112.03 ppm. All samples had the same retention duration, which 2.48 minutes, demonstrating the method's dependability. According to these findings, energy drinks have more caffeine than ordinary sodas. High-performance liquid chromatography (HPLC) is an effective and reliable analytical technique for detecting and quantifying caffeine in various beverages such as Coke and Levita. Through HPLC, the caffeine content in these drinks can be accurately measured, allowing for a better understanding of their composition and compliance with regulatory standards. The results obtained highlight the difference in caffeine concentration between carbonated soft drinks and energy drinks, with Levita typically containing a higher caffeine level than Coke due to its formulation as an energy booster. Overall, HPLC serves as a precise, efficient, and reproducible method for caffeine analysis, making it a valuable tool in quality control and food safety assessments.